Question 54 is kind of an interesting thing to think about. It really helps us bring together the last two modules. This module looking at solubility and the previous module looking at pH of solution. So we're given the KSP of iron 2 hydroxide as 1.8 e to the negative 15. And then we're asked at what pH will a 0.4 molar solution of iron 2 plus begin to show precipitation of iron 2 hydroxide. Before we get started, be careful. Your concentration of iron 2 plus may be different than my concentration. What we're looking for is, right, what does this ionization look like? So we've got iron 2 hydroxide. Iron 2 hydroxide ionizes to give us iron 2 plus and 2 hydroxides. And basically, we have this concentration already. So thinking of our KSP expression, right? KSP for this would be what's the concentration of iron times the concentration of hydroxide squared. We already know our concentration of iron. And that's all that it's asking is basically, given this constant, this KSP, the solubility product constant, and this concentration of iron, well, what would be the concentration of hydroxide in solution? And from that, we can then find our pH, right? KSP, that's a constant. That cannot change. So the product of these two, the product of iron concentration and hydroxide concentration, that needs to be a constant. So we know the concentration of iron 2 plus. We can find the concentration of hydroxide. So taking a look, I've got KSP of 1.8 e to the negative 15 equals my concentration of iron is 0.40. My concentration of hydroxide, I don't know, but that concentration we can call X. And because it comes into our KSP expression, it would get squared. Divide both sides by the 0.4. And I get X squared equals approximately 4.5 e to the negative 15. Square root of both sides to get x by itself, right? X equals 6.71 e to the negative 8. What is x, right? This is my hydroxide concentration. Now that we know the concentration of hydroxide, we can find the pOH of that. All right, so step 2, we know pOH equals the negative log of my hydroxide concentration. So the pOH of this would be the negative log of 6.71 e to the negative 8. All right, pOH is 7.17. Well, we know pH plus pOH equals 14. So the pH of this solution would equal 14 minus 7.17. The pH of this solution is 6.83. As you can see, this is actually an acidic solution, right? We're below a pH of 7, but that is just a sign of how insoluble iron 2 hydroxide is. At a very low concentration of hydroxide, 6.1 e to the negative 8, we'll start to see precipitation of iron 2 hydroxide. First, we had to find the concentration of hydroxide, knowing the concentration of iron in solution and the KSP data. From that hydroxide concentration, we could find pOH and subsequently pH of that solution.